Here I would like to teach you the method of substitution to find limits. It's a very helpful method to find limits. You can simplify your expressions very easily by substituting. Now here is how it is to be done. In this question we have limit of the function as it approaches minus 1, and the function is x to the power of 1 over 6 minus 1 and x minus 1 in the denominator. Now this kind of a difficult question. Whenever you have radicals, it becomes really difficult. So we can simplify it. How? Let's substitute. So this time what we will do is we'll substitute x to the power of 1 over 6 as, let us say, some variable u. Okay. Now if x to the power of 1 over 6 is equals to u, then what is x equals to? Then we have x is equals to u to the power of 6. Is that okay? Yeah. So what we can do is that we can replace x with u to the power of 6 and x to the power of 1 over 6 with u, right? And also when we are replacing all these things, we have to replace the x in the limit, right? Because we are replacing a variable with another variable. So what happens when x is approaching minus 1? That means what happens to u as x approaches minus 1? If minus 1, actually this question, it should be x approaching plus 1, not minus 1, because if it is minus 1, I could substitute minus 1 and get the answer, right? Minus 1 will not give me 0 over 0, right? So it's a typing error. It's good, I checked it. If I write minus 1, I hope you understand, if I write minus 1 here, I get minus 1 as minus 2, so I don't get 0 over 0, right? But if I write plus 1 here, then what happens? If I write plus 1 here, then it is 1 minus 1 is 0, right? So we get 0 in the denominator. And 1 to the power of anything is 1. So 1 minus 1, we get 0. Now we get 0 over 0, right? This 0 over 0 has no meaning, right? So we can't just substitute and get the answer. If it was minus 1, it was easy. We could have just plugged in minus 1 and get our answer, right? So if it was minus 1, then minus 1 to the power of 1 over 6 will give us 1. And 1 minus 1 is 0. So that should have been the answer, okay? But what I'm trying to teach you at present is substitution method, and this question is a typing error. So we'll write this as x approaching plus 1, okay? Now back to the question. So we substituted x to the power of 1 over 6 as equal to u, and therefore x is equal to u to the power of 6. Now think like this. As x approaches plus 1, what happens to u? So if x is approaching 1 or x is equals to 1, then 1 to the power of anything is 1. So u is also approaching 1, correct? That's what it is. So now what we can do is we can rewrite the question using u instead of x, and then we get limit, and instead of x we'll write u approaches 1, right? For this is written as u, right? U minus 1, and x minus 1, x is written as u to the power of 6 here, u to the power of 6 minus 1. Do you see that? So we changed the question and we substituted x with u to the power of 6 and x to the power of 1 over 6 as u, okay? Once you do this, then you can actually expand the denominator, correct? You know, it is kind of u cubed minus 1. Okay, so we'll expand this and we get here u minus 1, and the denominator, you could think this as difference of cubes, right? Or you could also do like this, u cubed plus 1 times u cubed minus 1, right? If I do that, then if you expand it, you get u to the power of 6 minus 1, right? So it could be thought like this. So what we are trying to do here is we are seeing u to the power of 6 as u to the power of 6 as u square, u cube squared. Do you see that? So it becomes difference of squares, right? So we just cube squared. Now we can further expand these terms, right? So now the denominator, u cube plus 1 and u cube minus 1. So what I will do is I'll expand only this one because I want to get rid of u minus 1 in the numerator. So I have u minus 1. Here I have limit u approaches 1 and I'm retaining u cube plus 1 as such. And I'm expanding u cube minus 1 as u minus 1 times u square plus 1 plus 1, correct? So that is the expansion of, I hope you remember, a cube minus b cube, correct? So we have used two formulas here. So here the formula we used here is a cube minus b cube equals to a minus b times a square plus ab plus b square, correct? That's the formula we used here, right? And here we use difference of squares. We say a square minus b square equals to a plus b times a minus b, correct? So that's what we used here to expand. Now you see common factor u minus 1, that can be cancelled out, and so we are left with limit u approaches 1, and here we can write as 1 over u cube plus 1 times u square plus 1, this will be u, not 1, u plus 1, right? A times b, so a is u and b is 1, so u square plus u plus 1. Okay, now we can substitute u as 1. So if I do that, I get 1 over 1 plus 1, which is 2, right? And here I get 1 square is 1, so 1 plus 1 plus 1, which is 3, correct? So I get 1 over 6. So that is how we can simplify this complicated question, right? So we used substitution first, and then we used our knowledge of factoring, correct? A cube minus b cube and a square minus b square, difference of squares and difference of cubes. And finally, after cancelling out the common factors from numerator and denominator, we got our answer, and that is 1 over 6, right? So this substitution technique is very important, and it can be used in many different ways. So you can try a few questions. Let me give you one here. You can substitute and get the answer for this one. And let's say we have a question saying limit x approaches 4 for square root x minus 2 over x cube square root minus 8. So that these are in the radical forms, right? Here you can substitute what this is, right? You can substitute this as u, right? And then figure out what, or you can substitute square root x as u, correct? And then get your question in, and then you can use a cube minus b cube to solve it. Is that okay? Try to do it, but don't forget to replace this value also, correct? So if you substitute, what I'm trying to say here, as I'm not solving the problem for you, but I'm trying to give you a hint. If you say, let's say any variable, we can use variable, let us say p, for example. Let's say p equals to square root of x, right? So in that case, p square, p cube will be equal to this function, right? X cube. Do you see that? That's the replacement for these numbers, correct? Second is, as x approaches 4, right? So we say as x approaches 4, then what happens to p? So p is square root of x, right? So p approaches square root of 4, which is equals to 2. So the question will change, and the question will then become, let me write it in a different ink, limit p approaches 2, correct? And p minus 2 over p cube minus 8. And you know 8 is 2 cubed, right? So you can expand the denominator and then get rid of the common factors, substitute p equals to 2, and get your answer. Okay, so this is a very helpful technique, and it helps you solve many problems with especially radicals. Okay, I hope you appreciate it. If you have any difficulties, write down your comments and then we can do some more examples and work it out. Thank you.